welcome back to another one of my videos. In this video we're going to be looking at my new cover for the Avanti and Mammoth heads, and let's see who wins the battle between the Avanti head and the Mammoth head. Okay, first of all we'll make some comparisons. This is the Ron Moss Avanti head that was done originally for the Avanti cylinder kit that he made. As you can see, it's much larger than the original head. It's got way more volume. It's got a central squish, and that's basically been carried on to the Mammoth head. Now this is the Mammoth head, which is also same centered squish, same sort of design, except now it's got extra finnage on the back of the head, which will probably pick up more cooling than what the front will, as you'll see in some of our tests. Other than that, it's pretty well the same. So if you turn them over, you can see there's not much difference in it whatsoever. It's almost identical. So this is the new cowling that I've made for it. It's deeper than the original head cover, and it's also got an intake, some ducting, extra ducting in the head to enable more airflow over the top of the cylinder head. So we're gonna put on the Avanti onto the our dummy engine here with the original cover, and we can see more or less how it fits, but with a standard barrel, which most people are running TS1s or something like that. So let's have a look. Okay, first of all, here's the Ron Moss head. This is just a standard cast iron barrel. I didn't bother putting a TS1 on to show any differences, because what's important is you see the volume of size here in the head and the barrel is a huge difference, but you now have a gap on the barrel when you put the cowling on. So this gap, which I'm going to show you in a minute, allows lots of air to escape when you're trying to cool the head. And you'll notice that the head cowling fits quite tightly, so therefore you've got a restriction of air flow over the head and loads of places for it to escape on the barrel. On the original design for the cowling has to run close to the finnage, therefore forcing air between the fins to remove the energy. If you've got a big massive gap, the air doesn't flow through the fins because it's far easier to just escape over the top or underneath. Okay, you can see the absolute huge gap between the cover and the cylinder. Yeah? This allows almost all of your air that's supposed to be cooling your cylinder head to escape straight over the barrel. And if we look inside here, there's a huge gap down where the exhaust goes. Absolutely massive. So you can imagine the amount of air that's going to escape there. We're going to be doing some tests later on in this video to show just how much air flows over the head and how much air goes over the barrel and escapes to nowhere. Sorry, this one is the Mammoth head now. As you can see, it's got the finnage on the back that's actually overlapping the fins on the barrel. These fins on the back are actually going to probably get more airflow than the front, because the cowling doesn't supply enough to it. It's got some holes made through it to allow air to pass through, but I think that the holes that have been put in are probably not going to work, because as you've got massive flow in this direction, right, you're creating a negative pressure. So these holes are actually going to create suction, not flow. It's probably going to pull air back out through there and that way. the same as if you're blowing air over a jet. If you blow air over a jet, you're sucking through it, not blowing through it. So I reckon it could actually be worse having the holes in than having no holes at all, because these holes will get a negative pressure on this side, therefore the air will be sucked out from the head rather than blowing cool air through over the head. So the only air you're going to get is whatever gaps around the outside. The holes, I'm not 100% sure whether that's a good idea or not. So, as you've seen, big massive gaps with the original cover. It's been cut away massively. I don't know why they've cut all this away, so it fits on everything. Bad idea. So, I've now made another new cover for it, and this is it. Just drop it in place. So, as you can see, a few hand marks on it. I've now filled all that in on this new cover, so you can then cut it as close as possible to fit in your manifold, whichever manifold you got, TS1, RB, RT, with the normal manifold, whatever you're running, if you want to run this big head with it. So now it's much closer. Underneath, I've also closed up around the exhaust as tight as possible to hold in as much air as possible. So let's have a look around this one. So as you can see, there's still a massive gap between the barrel, but less places now for the air to escape. And underneath, inside, you can see the reduced area around the exhaust port, therefore keeping more air in. So what we're going to do is we're going to make some stuffers that fit in once this cover's on, that actually flow the air through the barrel fins and stop it escaping. So there'll be a special stuffer put in the bottom and another one in the top. So they have to be made. Okay, so what we're going to do next is we're going to set up a little flow test the best I can with what equipment I've got. I'm not in a laboratory, so don't expect lab technology. So it's going to be just an air gun basically, and an anemometer to check different flow from different areas. So let's have a look at what we're going to do. Okay, so I've managed to mount the my hot air gun, which I've turned down to 0. Luckily I've got I can turn the heat down on it, so it just basically blows cool air. And we've just taped this up, so we're pushing as much air as we can over the cowling, and we're going to take some tests with an anemometer to see how much air passes in the various areas, and then we'll test the other head. This at the moment has got the mammoth head with my cover on it, so let's see how that gets along. Okay, we're going to do a test now. This is my cover with the vent on the side, and we're going to take an air test, speed test in meters per second, what we're getting over the cylinder head in this position. So we'll turn our fan on, which should be the same speed every time because it's not a flywheel, it's a fixed fan. Let's go. Right, so we're going to be using meters per second. And we'll set it on max, so it memorises the speed. Right, first test number 1. And we have 1.6 meters per second. 1.6 meters per second. Right, let's take it all off and do the next test. Okay, this is the next test. This is the mammoth head with the cowling that comes with it. You've got a spark plug hole there, so we might lose a little bit there. might get a slightly different reading, but let's see how much is lost and whether my actual vent that I put in on the side flows more air or not. So let's go for the test, shall we? So, fan on, select max, let's go. Okay, we've got 1.4 meters per second. So from 1.6 meters per second to 1.4 meters per second, it's quite a difference. So, next test we're going to do the Avanti head. So this is all coming off again now. Back with the spanners. Okay, so that's the mammoth off. We're going to put this Avanti head on. Just going to drop it in place. It's only a test. Right, so first of all we'll do it same as before with my cover. Nothing's been changed. Only the head. I'll screw this back up now and make the test again and see if the mammoth actually, with its holes in, flows any more than what the Avanti does. Right, let's go for it. Fan on. So we've had 1.6, 1.4. Now let's have a look. Come on, reset. I'm not very good with digital stuff. Okay, max, here we go. So look what we got. Wow, huge difference. The Avanti pushes 1.9 meters per second. Why? Surely the mammoth should be better. But the Avanti's flowing more. Is that the holes that I thought about? Are the holes creating a negative pressure and sucking instead of blowing? Possibly. 1.9. The Avanti flows more. That's a surprise. Wow. Okay. Well, we're swapping covers again. Now with the original Avanti head cover with the Avanti head. Let's get it screwed on. And let's go for it. So, turn this back on again, get it ready. Max so it memorises. Hit the fan. Fan's the same speed, fan hasn't moved. Let's have a look at the next result. .3. That don't make any sense. Put it back on again. .3. It doesn't go any higher. So that's a bit strange. So it's actually a lot less with this cover. 1.9 with my cover, 1.3 with this cover on the Avanti. But maybe we should retest the mammoth again. Maybe we're getting some wrong information here somewhere, because it doesn't make. Turn that off. We've gone from my cover with the Avanti head being 1.9 1.6 with the standard cover 1.4, 1.6 to 1.4, and then with the Avanti head and my cover 1.9, which was a big surprise, and then down to 1.3 with a standard cover. Not quite making sense. So let's do the mammoth again. We'll give it a second chance, shall we? Against that one, or shall we test? I think we should test them all again. Double tests on each, just to make sure. Right. Avanti head. Put my cover back on. This is the second test on this one, and let's see if we get the same result as we had last time. Because we got 1.9 meters per second, which I was like, what? That's huge. So we'll test it again. So fan on. Reset it. Meters per second and max so it saves. So we'll do it exactly the same again. Maybe there was some anomaly, something that gave us a different reading, I don't know. So there we go. Last time I got 1.9. Let's have a look what we get this time. 1.7. That's a little bit more respectable. So 1.7 meters per second with my cover with the venting and the Avanti head. Now we'll swap over and we'll put the mammoth back on to give it another bite of the cherry. And just so you see that I'm not cheating, I'm going to leave everything turned on and just do it quickly. We're not going to move anything. So, Avanti head off. Come on. I've had this off loads of times, come on. Okay. Mammoth head on. Cover back on, same cover. We just got 1.7. Let's see what we get this time. So, I'm just going to screw it up. Come on. Let's see if this mammoth head can make the 1.7 that the Avanti made. So there's something about this head, possibly, that's stopping flow. Is it the holes? We'll see now. Mammoth's second bite of the cherry. Max. Come on, baby. Now I've got 1.8. It just keeps changing, doesn't it? So we've just got 1.8, we'll do it again. So they're more or less the same. 1.7, 1.8. If I do this again now. So the 1.9 was a bit of a freak measurement. But this got 1.6 before. .7. So they are, the Avanti and the mammoth, really they're flowing more or less the same. There's nothing much in it. Averaging 1.7 meters per second. So we got a 1.9, which was, yeah, wasn't a true reading. So we've had 1.9, 1.8, two 1.7s, so we'll go for the minimum one at 1.7. So we can say that the mammoth and the Avanti head are flowing 1.7 with my cowling on. So should we have another go with the other cowling to make sure, double sure. Obviously more tests you will get a more accurate reading eventually. With the more tests you get an average. So we'll do another test with the standard cover now. Here we go again. Okay, this is the final test to see what difference this will make. I've put now stuffers in. So I've got a stuffer in the exhaust port to stop airflow being blown down the exhaust port and to take up the gap between the fins and the cowling. So the air across the bottom is forced through the fins. The same on the top. I've blocked the air from escaping and blocked up the gap between the cowling and the fins to force air through the fins. Now what this should do is create resistance. You will now should in theory get more airflow across the head. How much it's going to be, we're going to find out now. Right, so this is the big one, whether my theory of the stuffers is correct. On with the fan. Zero our machine. Select max and back over the top of there. This is my cover with an Avanti head and the makeshift stuffers, which I haven't made the proper ones yet. I've made it out of plasticine for now, just to see what the results will be. Right, let's have a look. And there's already a difference. 1.9 meters per second. We'll do it again to be double sure. Fan off. Zero the machine. Set it to max. Put the fan back on and let's test. Come on, baby! I think that should be enough. Okay, this time I got 1.8 meters per second. Got 1.9 and 1.8. So it improves the airflow over the head by putting in stuffers. But I've still got airflow coming through the fins. In fact, I couldn't feel airflow through the fins before. So now you're getting flow on the fins. Before there was so much gap that I couldn't hardly detect any airflow coming through the fins before. Now I have got airflow through the fins, whereas before it wasn't happening. So we've deflected some up to the top and we've now made it more efficient across the fins. It's the way to go. Well, I hope you didn't get too bored halfway through and turn off and go, oh, more tests, more tests. Yes, more tests. We do like tests. The more the merrier. Anyway, proof is in the pudding. Stuffers work. And I think the actual ducting that I've extended on the side here has made a huge difference as well. So I'm really pleased with the results. And now I'm happy to say that a mammoth head does work. As before, maybe not so well. So don't forget to subscribe to my channel, share and like with all your friends. I'll see you all later.